Talking about dimensional analysis, and today we are with a question. This is the dimensional formula for magnetic flux density is what? Is either of these options. So let's try to get it. Firstly, we know that magnetic force is equal to the quantity of charge multiplied by the vector speed with the cross product of magnetic flux density B. And we know that the cross product between two vectors is equal to the magnitude of those two vectors multiplied by the sine of the angle between them. Then I'm having to modify my equation. I'm having F is equal to QVB sine theta, where theta is equal to 90 degrees. Then sine theta will be equals to 1. So F is equal to QVB. Now our aim here is to make B subject of formula. Therefore B is equals to F over QV. We divided both sides by our charge and our velocity, QV. Now to get the dimensional formula for this, we need to get the dimensional formula for each of the quantities here. Firstly, let's start with force. Force is equals to the product of mass times acceleration. Mass, the unit is kg, and represented by a capital M, while acceleration is the derivative of velocity. Then I can do this as LT minus 2 as the dimension for acceleration. So this is the dimension for force. Next we get to our charge Q. We are to get this from our current I. Current is equal to the quantity of charge all over time, where we cross multiply. Q is equals to I and T. Since current is part of the fundamental formula or fundamental quantities, and time is also the fundamental quantities, we leave it as it is, T. So this is the dimensional formula for our charge in coulombs. Now to get for our velocity, speed of charge is equals to displacement all over time, and this is L over T. I'm written as LT minus 1. So we have gotten the dimension for our three variables here. So let's apply them for formula. So B is equals to, for the first we got MLT minus 2. This is MLT minus 2. And beneath it I'm having my quantity of charge here, IT, and for my speed V, I'm having LT minus 1, LT minus 1. So to simplify this length, we cancel this length. I'm left with MT minus 2 all over IT multiplied by T minus 1. So with our idea of indices, these two are supposed to cancel. This is having a negative 1 plus 1, t raised to the power of 1 times t raised to the power of negative 1. It will cancel both of them. So finally our magnetic flux density is MT minus 2 all over I. So writing all this in linear form, I'm having B is equals to M I minus 1 T minus 2. So that's the dimensional analysis for magnetic flux density. Therefore our answer is option C. So thanks for watching today's video. Don't forget to like and subscribe to the YouTube channel.